Welcome to session 6 of day 2 of the 2025 RNG Technical Symposium. So in this session, we'll hear from Ivis and talk about PSA upgrading and CO2 recovery. So with me now, I'd like to introduce Anand Vasudevan, Director of Business Development and Strategy. And Anand, go right ahead.
Thank you, Paul, for the introduction, and apologies, folks who've been waiting. Really unnecessary, like a technical glitch out here. So I'll breeze through our presentation a little bit and then save some time for Q&A at the very end of the presentation. So Ivis is a company that was founded in 2023 by acquiring the assets of former company Zebeg that's been around for a couple of decades. We're headquartered in Quebec, north of Montreal, in Blainville. We have over 100 plus staff covering the value chain of like engineering, supply chain, design, and manufacturing, and customer service as well. Our mission is to enable circularity by primarily the three molecules of carbon dioxide, methane, and hydrogen. I don't know why this, but hang on one sec. Yeah, sorry. So we directly plug into the enabling the circular economy value, waste to value, across a variety of like biogenic feedstocks from agricultural waste, food waste, cow manure, industrial wastewater, as well as food waste, through both sort of anaerobic digestion processes as well as syngas, and enabling sort of direct sort of like commodities as well as like indirect commodities for fuel grade hydrogen to sustainably efficient fuel, methanol, methane, as well as obviously the other routes would be like other commodities like electricity and heat. So the core of our sort of like technology is really a pressure swing adsorption, which I'll go into detail. But this one basically illustrates our sort of graphic about we over 450 deployments like globally, where the application of rotary valve in sort of optimizing the pressure swing adsorption process is utilized in biogas upgrading, hydrogen purification, carbon capture, also helium capture and upgrading, and oil and gas purification industry sectors. So when it comes to just around like biogas upgrading applications, we have over 95 deployments globally. The most mature markets having been like Europe, and North American market is sort of like now ramping up and maturing. We're also like directly plugged into developing sort of other markets such as like Asia. Again, the direct link sort of like talks about the sources of feedstock, across dairy farms, organic waste diversion and treatment, landfill gas treatment, co-digestion of animal waste and farm waste, and wastewater treatment facilities. So talking about really core of our technology, as I said earlier, is the adsorption process, which includes both the temperature swing adsorption for dehydration of air, methane, and hydrogen, and the pressure swing adsorption process for purification, upgrading of the molecules. At the core of our differentiating IP intellectual properties are rotary valve technology, which differentiates our product from conventional sort of like PSAs, the advantages of which I'll go over in a few slides. But typically what this does is like results in sort of like optimizing the sort of like the CapEx and the OpEx of upgrading sort of like a system stack on the value chain for developers. Here's the sort of like the advantages. I'll go over it. So conventional PSAs on the left-hand side, as you can see, is like, a lot more sort of cylinders and like a larger volume of adsorbents and complex sort of like piping with like a numerous sort of switching valves and solenoid valves, as opposed to our product through the rotary valve PSA, which results in like a much more optimized sort of like solution design with a much more faster cycles, which basically what we mean by faster cycle is like the resident time of the gases involved in the adsorption desorption process are like a much more quicker and faster, resulting in the need to have like a lot less volume of adsorbents and steel. So our vessels are typically anywhere from like 5 to 10x like smaller, very minimal piping. And we have 2 rotary valves, one on the top of the sort of like vertical PSA beds, as well as one at the bottom. One is really the feed valve and the other one is a product valve. This results in like sort of the gases being like constantly flowing between all the beds in a continuous flow. And there's only one single point of control, which is a rotary valve, as opposed to a conventional sort of like a PSA. We have multiple points of control, and that leading into multiple points of failure as well. We have a whole catalog of valves to treat different gases, gas compositions, and flow rates. The smallest sort of like valve is G1 PSA, which addresses all the way down to 15 to 45 NMQ per hour, all the way to the G0 valve, which goes all the way to about 15,000 NMQ per hour flow rate. So as you can see, really, the constraint is really on really the flow through. And we sort of engineering disciplines are really about like the different sizes of the valves and trying to put together different sort of like bed compositions and sizes of the tanks and so on and so forth. And to plug into the various sort of global markets, the vessels are like compliant to ASME, CRN, and PD. As the previous slides talked about, we are really addressing like a global market need. This slide really talks about the hydrogen sort of value chain as well, where PSAs are, we have over 350 deployments of a PSAs that addresses the various sort of like hydrogen value chains, hydrogen from gasification, pyrolysis, and other biological processes, as well as distributed hydrogen generation from reforming for hydrogen refueling stations and industrial usages, on-site hydrogen generation via small-scale reforming for vehicle refueling as well. And of course, the ammonia cracking, hydrogen purification from ammonia cracking, and hydrogen recovery from industrial gas processes. This slide really is a regurgitation of the previous slide. Talks about a global install base of over like 100 plus deployments worldwide. We have really plugged into dairy farms and organic waste diversions, food waste, landfill gas, upgrading wastewater and industrial wastewater treatment, and co-digestion of animal and farm wastes. So what's a typical sort of like, I mean, this is obviously everyone knows about this, but I'll just quickly illustrate like, what really the sort of high level differences between our system versus some of our competitors. A typical sort of a low pressure cycle in terms of like post digestion is like removing all the sort of impurities depending upon the various kind of feedstocks. There are various stacks out there. And what's relevant to our cycle is really, we want to talk about the difference between not having to remove some of the impurities, which would be intolerant to other side of like upgrading systems, but the PSA membranes, PSA systems are a little bit more tolerant to some of the impurities such as volatile organic compounds and siloxanes up to a certain level. But it is a regenerative cycle versus some of the upgrading systems such as membranes. It becomes like a non-regenerative, permanently damaged sort of like stack as well. So this slide really illustrates the various types of impurities and the range of impurities based on the source of biomass as feedstocks. Again, this one really talks about the need to have like a robust, well thought through pre-treatment sort of like set of subsystems in order to address the upstream risk before it comes down to the main sort of core upgrading stack, whether it is stick built PSAs or conventional PSAs or rotary valve PSAs or membranes, and the degree of tolerability to which like some of these subsystems address. And we believe that the PSA systems are like a little bit more robust, And obviously, not saying like there is no innovation going on in other forms of stacks as well. So I want to divert like the sort of like a talking points from what we've seen over the sort of like our experience in markets over the last like sort of several decades into bringing a more of a product-based approach towards like biogas project development. And the reason as to why I think it's more compelling and why it's being like adopted a lot more in the marketplace as well. And this one really is like a timeline in terms of like some of the projects that have been involved in from over the years since like early 2010 to 2018 in global markets. And when our first sort of like Gen 1 biostream, which is on the right-hand side, you can see like a 40-foot container, which is like a modular, sort of like a self-contained plug-and-play system that I'll go over in a little bit detail. So this is the containerized solution, which is capable of processing anywhere all the way up to 280 SFM standard cubic feet per of flow rate. The turn-down ratio 20 to 100%, with a recovery of 99% plus and 97% purity at about 20 plus years of lifetime. So why biostream? From issues to risks. So these are some of the risks that we've been seeing through our experience in terms of project execution, delivery risk, in terms of like a conventional stick-built PSA approach versus like a product approach. On-site electrical, plumbing, and manufacturing requires like multiple stakeholders or multiple throats to choke, whereas a single throat to choke. Lots of sort of site controls needs to be integrated on site. There are surprises related to like an on-site testing that you obviously nobody wants to like sort of encounter. Site commissioning issues, which typically ranges anywhere from 15 to like 25% of the overall cost of project implementation, delays in permitting, and obviously weather plays a very, very, very interesting role as well in some of these projects that is leading to longer delays. So what we've done is like sort of internalized all these sort of externalities and risks into figuring out like what would it take in order to have like a standardized sort of like a product with as many of these sort of things that are self-contained and containerized and modular and pluggable and also additive in nature, right? So we have standardized the modularization. We minimize like on-site work to about like from 3 months to about like probably like 2 to 3 weeks at the most. This is like factory tested and approved from Intertech certified. So literally every product that goes out the door is pre-approved and tested and commissioned to be sort of like in a commission. Site acceptance test risk is also very minimized. And also you could have like a standard sort of like protocols and processes in place to install at multiple sites with the same sort of like a process and interface as well. And another big value add obviously is the IoT sort of like control, through which now you can have like if you have like a network of these sort of like modularized products across multiple different sites, you have like ability to troubleshoot and with the same sort of like risk tolerances and also capabilities to fix at the real time. This particular slide really talks about how a product is built. This is a dewatering and condensate removal system. That's a feed compressor. This is a PSA upgrading system. That's a recycled pump. Control and electrical module. Compressed air system, oxygen generators, vacuum generator, gas analyzer, and lastly, the enclosure with a buffer tank and ventilation system like an onboard. and the rest of the sort of like bouncer plant, such as the H2S removal scrubber and VOC removal, all that. So as you can see, it's like really a sort of well thought through product, um, where it's like really plug and play and additive and modular. This talks really about some of our other slides. It's not needed. So this slide is a very cool slide. Talks about like how we are seeing our systems being deployed in the field very rapidly. All you need is like the foundation to be laid out in the field, and up comes the crane and drops the 40-foot container, and then on top of that is really the buffer tanks and everything else. Literally, this whole operation takes about less than like 2 to 3 weeks. This one talks about like 2 buy streams, like late side by side, capable of generating about 5 to 10. I mean, each module is about like 5 to 5.5 tons, and then now we have over like 10 tons per day systems. So we have currently over 11 sites with about like 19 units deployed throughout North America. So again, terribly sorry if I have shot the whole shot, and hopefully I can take in some questions.
Okay, thanks, Anand. The question came in on manufacturing, and I answered it that the fab shops in Montreal. I don't know if the question was kind of pertaining to domestic content concerns, but I had a chance to tour the fab shop tour the fab shop in Montreal. It's a beautiful facility where they're making these PSA vessels, and lead times are extremely competitive, prices are extremely competitive, and so they've had a lot of success of late in both food waste AD as well as dairy opportunities as well. Bunch of projects, there's a dozen of them in Iowa currently up and running. So I think for now, Anand, I don't see any additional questions. So appreciate you joining in here. And anything you want to share on CO2 recovery? I know that seems to be an up and coming thing for IVUS. It's early days. Any wisdom to impart there, or too early to talk about it?
No, I think that's a good point, Paul. Yes, we definitely will be coming up with some sort of announcement fairly soon. But yeah, it is an important part of our additional sort of continuing to look at expanding horizontally in terms of value chain to our existing platform with a carbon sort of a liquefaction sort of like a stack that's bolted on. And again, but the point to really make is really we are looking after like point source, like carbon anywhere from about 8 to 32 tons of carbon from any site. Yeah, I mean, that's really the range of the point source that we're looking at, but there could be like other larger subsystems also we're looking at. And the various sort of like industries that we're looking at, like data centers and existing like biogas facilities, and other like post combustion natural gas post combustion like processes as well. And yeah, I mean, this is exciting times with looking at additional sort of like expansion of our product roadmap to address like more scenarios. Yeah.
And you guys have been doing a lot of work lately in the gasification space as well, with things like H2 carbon monoxide separation. So your PSA skill set is beyond simply CO2 methane separation, right?
Absolutely, Paul. I think, yeah, that's like that was the reason why I wanted to show about like the role of the PSA process in hydrogen purification, and how that sort of like market's also shifting a little bit, as you know, because of the tremendous lack of clarity in the 45V tax credits out here. The electrolytic route for green hydrogen production is like sort of like contracting, not only in the United States, but also in like other global markets as well. So I think markets are sort of like reshaping the definition of green to start looking at biogenic sources of hydrogen production, And obviously, as you know, Paul, I mean, this is really the gasification pyrolysis routes as well. So you're seeing a lot of uptick in terms of viability of green hydrogen through these other vectors of hydrogen production, where our products are, I mean, the PSA, the role of PSA specifically in coming down with like a much more lower cost for the molecule at the end is like, really playing a critical role. Yeah, absolutely, you're right. You're seeing a shift in the markets, as well as like the definition to include the more other sources of hydrogen generation. And I would add like also other derivative molecules as well, right? So absolutely.
Good. Well, you've been requested to share your contacts. So if you have your contacts on the final slide, we can get those slides up on the website tonight, if that's okay. Can you send those over?
Absolutely, Paul. I'll do that.
Okay, very well. So thanks, Anand, for your time. Good to see you. And yeah, for the folks not very familiar with the IVUS brand yet, so ZBEC was a thing back in 2020 and before time, and ZBEC has gone through a restructuring, now came back out as IVUS. So one of the granddaddies of the biogas RNG upgrading, hydrogen gas drying space. So thanks for joining us today, Anand.
Thank you very much, Paul, and apologies, folks, again for the technical glitch.
Yeah. Okay. All right. We'll let you go. We'll see everybody in 25 minutes, top of the hour. We're going to talk some more about membrane gas upgrading and use of membranes to strip out hydrogen sulfide. So we'll see everybody at the top of the hour. Thank you.